All right, everybody, good morning and welcome to another webinar. We're sitting in the month of April. Can you believe it? Time is flying dramatically, and I know the month of April and May, we've got quite a few events happening. So we're looking forward to that, and Carl will tell you a bit more about that. Just a couple of things from our side. Just a reminder, the session is being recorded. If you'd like to access the video or send the link to anybody afterwards, the recording as well as the presentation will be made available on our website during the course of early next week. If you have any questions for our speaker today, please feel free to pop them through to us, pop them on the chat function. You can raise them afterwards. We'll stay online for a minute or two. And then, of course, we'll be sharing Philip's details as well, that you can contact him directly. Philip has recently become the proud papa of a little girl, my daughter's namesake, which is very, very, very cute. And we were having a nice little chat about that earlier. And we were saying that he looks way too fresh-faced for a new daddy. But I'm sure he'll tell us a funny story or two as he's talking. Philip is a wealth of knowledge, and we've been very, very fortunate to have met him a number of months ago and to have worked with him thus far. So I'm sure that you're all going to enjoy listening to him today. On that note, I'm going to hand over to Kyle, and Kyle will tell you a little bit more about the upcoming events and the webinar itself, and then he'll hand over to Nicole Nel, and she will do Philip's introduction before popping off, and then, of course, the man of the hour will hand over to Philip. Kyle, over to you.
Thanks, Linda. Good morning, everyone. I hope that everyone is doing well, and thanks so much for tuning into our webinar this morning. This webinar will be recorded and published on our YouTube channel, as Linda said, so please remember to like, subscribe to our channel. We would really appreciate it. Then if you haven't already, please do sign up to our newsletter. This way you can keep in touch with the TVDM consultants team. Please also don't forget to check out our neighborhood. If you have any questions, please send them or email them to me, and you're welcome to take out common property or the managing agent package to explore the platform at no expense. Make sure to also get your NAMA Community Scheme Expo tickets. This is happening on the 18th and 19th of May at the Gallagher Convention Center in Johannesburg. I'll add the link below if anyone would like to buy tickets. If you are looking for any training, then please also check out Stratafin's Trustee training in conjunction with TVDM consultants, and I'll also post a link below. We hope that everyone enjoys today's webinar. Thanks. Right over to Nicole.
Morning, everybody. I'm so sorry to be missing the webinar this morning, but in anticipation for the wet weather coming up, I need to have a headlight replaced. So that's unfortunately why I'll be missing it. But on to Philip this morning. So a bit about him and Naba. Naba Consulting is a multidisciplinary consulting company specializing in building maintenance, repairs, and upgrades with offices in the Western Cape and in Gauteng. Their team consists of engineering, architectural, quantity surveying, and construction management expertise. Philip himself is a professional structural engineer that graduated at the University of Stellenbosch and started Naba Consulting in 2016 after working as an engineering consultant in the new build industry for 5 years. Over to Philip.
Thank you so much, Nicole, and thank you everybody at TVDM for this amazing introduction. I don't think I felt so proud before ever, well, apart from when Olivia was born. So thank you so much, everybody, for attending. And the reason why I'm looking so nice and fresh is because Charlotte, my wife, has helped me out so much, and she's taken care of the baby last night so well so that I can sleep in and look fresh for today. So I want to thank her for that. And she also helped me to put my presentation together. So special thanks to her. So I'm going to share my screen. I'm going to bounce around a little bit today between my screen, and then I'm going to go a little bit to a whiteboard so we can sketch and to make it interactive. So while I'm chatting, if anybody has a question during the presentation, please pop it or raise a hand or something like that. The purpose of this, which we'll get to, is not for me to talk. It's for everybody else to hopefully learn something. So, and you can only learn if you engage. So if you guys engage, it'll be great. So don't hold back. Okay, so let's start with the presentation. Okay, I think everybody can see that. Okay, so I'm not going to really introduce myself, but I'm a structural engineer, like they said before, and I think there's a sensor in here. I'm a structural engineer, studied at Stellenbosch, and we now specialize in assisting clients with existing buildings to make sure that their buildings are maintained well. So we've been operating in the sectional title industry for quite some time, and we've got a bunch of services tailored to assist people with existing buildings. And you can go to our website to see more about that, but I'll talk about that at the end. Then just quickly about the topics. So we're going to talk about waterproofing today, which I think is very fitting, seeing that, well, Cape Town is going into the wet season. Joburg just came out of it. So they will know exactly what the repercussions were of not addressing the problems, at the right time. And hopefully the people in Cape Town will then react quick enough. Then we're going to talk a little bit about walls. It sort of ties in with waterproofing. But I know in sectional titles and just existing buildings, walls are quite a hot topic, and you get different types of walls. So we'll just go through that quickly. And then I'm going to end off, which is sort of the common thread throughout the whole presentation. And that's just about tenders and sort of packaging projects and how you should approach a project when you want to do one. All right, so the goal for today is that everybody should try to better understand certain of these topics. We don't have enough time to become experts in it, but if you learn something, it'll be great. So like I said, please engage. Then what I want everybody to take out of this is, especially in this existing building industry and maintenance industry, things can get quite frantic because it's always a big issue, especially with waterproofing. So waterproofing and plumbing are mainly the biggest issues or sort of critical items in buildings. And then people rush into it and they try and fix things, but they don't spend the necessary time to actually take a step back, look at the problem, and spend time solving the problem before they go over to action. So I want everybody to sort of take that out of the presentation today, is don't try and rush things, rather do it correctly. And then it ties in with follow the correct process. Then also, we have to keep everybody engaged. So somewhere in the middle of the presentation, I'm going to ask a question with a multiple choice answer, and then somebody will win something. So you have to pay attention. Very important. I wish they did that at university. So then, okay, let's start with waterproofing. So I want to talk about sort of what causes water like ingress or problems at your building. So the thing is, and the first thing I want to talk about is sort of time. So let's say it rains, and you'll see that when you see damp in a building and you look for the cause, usually the reason for the damp inside your house or somewhere is because there is a flat surface somewhere where water can stand for a longer time period. So everything has some porosity in it. So even concrete, is porous. So if you have water standing on it, that you want that water to get out and away as quick as possible. That's why water don't necessarily come through vertical surfaces that easily, because it just runs off and it's away. But on a flat surface, the water stands there. So on your balconies, on your flat roofs, on your windowsills, that's typically where you have the issues. And that's because it's flat surfaces and water have time to stand there. So that's why if you sort of think about it as an equation, so if water ponds on a horizontal surface, if that thing underneath it allows water through, then if the water cannot evaporate quick enough, then it will go into that surface below it. So you want it to either run away or evaporate. So that's why if you put waterproofing over, waterproofing shouldn't be porous. So that allows the water to either then run away for over a longer period of time or evaporate before it can penetrate. So that's sort of the basic principle of it. Then water is a sneaky bugger. It will find a way in. So people think that, there's damp coming in through my ceiling here. I see a small crack there. Let's fix that crack. But it will find the next crack and it will get in there. So the typical areas, if you have a waterproofing issue, these are sort of the areas you have to look at. Because if you have a balcony now, for instance, the waterproofing issue is not,
Okay, can I please speak to Anya van Eden?
sorry.
Sorry about that, Philip. I've muted it.
Oh no. So so when you think about a balcony, the open flat area is not typically where the issue is. The issues are usually at penetrations through that surface. So if you have a balcony, and let's say for instance, you have an outlet somewhere, then that's where the problem usually lies, because it's very difficult to do the waterproofing properly. And there's also more movement there. And if you have openings, so window openings, like I briefly mentioned before, that's also a classic area where you have problems. Then any junctions or join in your slabs or any area, that's where you have problems. So your joints between your walls and your windows, your joints, if you have a big walkway or long walkway or something like that, usually that will have joints. And then water will get in there. Not always, but the possibility is the highest there because there's movement. And movement makes it tricky for that waterproofing to stay intact and to stay bonded and all those things. So then it allows water to go in. And then the same goes for cracks. So that's an opening. That's where water will then finally go in. So the crack in a slab is not the cause for the water to penetrate. That's just where the water eventually comes out. So the issue is that the waterproofing above it somewhere is failing. So don't think about the crack as the cause. If it's a very big crack, then yes, it can cause the waterproofing to fail. So, and then poor details. So we'll discuss the details, which is very, very important. We'll discuss that in more detail later. So details is just where you go into the outlets, where you get to the doors, how you turn up around the edges of a balcony. So you can't just tell somebody, waterproof my balcony. You have to tell them, waterproof my balcony, do this there, do that there, use this detail there. So there's a lot of detail that goes into it. Okay. Then, so now let's go to the why quickly. Why should you do waterproofing? These are sort of the three main reasons why. Most important, and the first two sort of tie together, but the first one, protect your structure, is more about protecting the integrity of the structure. So protecting your building as a whole. Do not compromise it and then have a building later that might collapse or something like that if you leave it for too long. So that is sort of the main reason. Then obviously you also want to protect everything on the inside of your building. So you don't want a lot of water to leak through your roof, and then it damages your entire ceiling and all your furniture and all those things. So that's obviously also a big reason. And insurances, will definitely back that up. And then health concerns. So if you leave buildings, the waterproofing not intact, and then you get a lot of moisture, then you'll get growing inside the unit. And I'll speak a little bit about that because there's sometimes a bit of confusion on that one. So protect your structure. I'll show you guys just quickly now some examples of what can happen. So a big thing about protecting your structure and a cause or a side effect of moisture ingress in concrete is spalling. So spalling is when concrete doesn't have a very good tensile capacity. That's why you have reinforced concrete, so that the steel can do the tension part, the concrete does the compression part. So what happens is that if moisture gets to your reinforcing in your concrete, that's one of the reasons for spalling, then that reinforcing starts to expand. So you'll see it sometimes if you see steel, then it makes these flakes on it. And that is sort of the process of it expanding for various reasons. And then because of that expansion, it then creates stresses in the concrete, which the concrete cannot handle, and it pops off. So you'll see in the next images what that looks like. So that's a big problem, because that then definitely affects the structural integrity of your building. So over time, the longer it goes on, that steel will get smaller and smaller and smaller, because that's what happens. It flakes off, and then it just loses its capacity, and then your building is compromised. The same goes with timber. If timber just stays wet all the time, so your roof trusses and things like that, it will compromise it, and it will not have the structural integrity anymore. Then I just mentioned it briefly earlier. So your ceilings and your furniture and stuff like that, you obviously want to protect that, and that's why you want to do waterproofing. Then mold, I mentioned that earlier. So I've seen this quite a lot in buildings where people think that, because I mean, whenever somebody sees moisture, they think, sorry, it's going to look like I'm looking for help, but it's not the problem. I'm fine. I'm fine here, everybody. Don't stress.
We'll keep an
So-
eye on you. Don't worry, Philip.
Yeah. So what happens, you'll see it a lot in bathrooms. So you get into a bathroom, you see all these dark moldy spots on the wall, on the ceiling, things like that. And then people's first like opinion is it's a water ingress, it's waterproofing failure from somewhere. But a lot of times it's just poor ventilation. So people don't open their windows. Then obviously you also have moisture. So it's moisture ingress, but it's from the other side, you know, and the moisture doesn't get away. So it's not from the outside, it's from the inside actually, because of, you know, all that steam inside the bathroom, it doesn't get ventilated. So now that surface just stays wet. So that's a very big misconception sometimes in buildings where we have to step in and say, no, there's actually no problem with the waterproofing outside. You just have to ventilate the room properly. So spoiling, this is what I explained earlier. So this is quite severe. And as you can see, like here, some of the steel or the reinforcing is basically gone already. So that's what happens over time. So the only reason, so there's different things. The moisture it's not necessarily always that your waterproofing at the top of the slab or something like that is failing. Can also be a problem that there's not sufficient cover to your reinforcing. So then moisture gets in from the underside. That's not a waterproofing issue. That's just a poor construction detail from the beginning. So that cover means that, so concrete protects the reinforcing against the external elements. So you want to cast the steel inside the concrete deep enough so that the external elements cannot get to it. If there's not sufficient cover over the reinforcing, then it's easier for, you know, water and oxygen and things like that to get to the rebar, and that will then cause the rebar to corrode and the concrete to spoil. Then the other thing that we discussed, this is a typical thing that people will see. So that's just paint bubbling because there's too much moisture in the wall behind it. So now that moisture then let the paint delaminate from the surface and causes bubbles, and there's moisture trapped behind the paint. So in those areas, there's just moisture trapped. That's why it's creating that bubble. And this you can see, so this is in a bathroom, but I can see from this that that's not the previous thing that I discussed where it's just moldy because of poor ventilation. As you can see, that's damp. So this is water that's actually ponding on the ceiling and creating that damage in the ceiling. So that's a waterproofing failure. So this is your typical defects that you'll see when you have poor waterproofing. So spoiling, see it a lot under balconies, under walkways, things like that, where there's just constant water ingress. And then obviously damaged ceiling, damaged paint and things like that underneath the areas. So I just quickly want to discuss, because if you think about it, if you had a perfect cube, which is your house or your building, without any openings, then you shouldn't have any problem. Then you just want to make sure that your external perimeter envelope of the building is nice and not porous and nothing can penetrate it. But obviously now you have to make it habitable. So now you punch openings all over the place. You create nice details, architects. And then with that, you then have to make sure that you do things properly. So start at the top. Usually when you have moisture problems or when you want to sort out the waterproofing at your building, start at the top and work your way down. Start with the roof, then horizontal surfaces or whatever, balconies, walkways. Then you go down to the bottom, look at retaining walls and things like that. So always start at the top. So roof, there I'm just showing you that's now a typical balcony or walkway in a building. Windows, that opening there is your window opening. Obviously, you get different types of window openings and all kinds of funny things. Then we have horizontal surfaces. So horizontal surfaces is just, it's mostly like top of walls. So top of like that wall there will be horizontal surface. Top of that wall there, top of this wall here will be horizontal surface. That windowsill there will be a horizontal surface. So there are actually quite a lot of horizontal surfaces around in buildings. And like I said earlier, horizontal surface, because it's horizontal, water can pond there. Stands there for longer. Because it stands there for longer, it has the time to then penetrate the surface below it. Then retaining walls, that's not necessarily a retaining wall, but it will be on the lower end of the building. And I'll explain retaining walls also a little bit later. So retaining walls also a big issue because you have moisture behind it. So that will allow moisture to penetrate the wall. But we'll go into that detail now. Okay, so roofs. Let's quickly discuss roofs and sort of typical issues and problems around roofs. So like I said earlier, the problem is if you had a nice surface without any penetrations or any holes in it, less problems. Once you start creating these things, these are typically like vent pipes through your roof for sewer stacks and things like that. That skylights, those things, problems, always problems. It doesn't mean you cannot do it. That's not the situation. You can definitely do it, and it can be done successfully. It requires more maintenance and it requires more attention to get it right. So I'm just showing you here a typical and nice detail for a penetration. And I'll just quickly take you through it. So what
Philip,
would happen is...
Sorry, Philip, just to interrupt you for a second. We know that solar panels really hot at the moment. Would the same thing happen with solar panels, or could the same thing happen?
Yeah, also very likely. So what is nice about the solar panel sometimes, let's say if you've got a sheeted roof. So if you've got roof sheeting, like corrugated roof sheeting or IBR roof sheeting, or sometimes like some things like that, then what they do is they can fix. So just by the way, very good question, Zelinda. What they can do is they use because obviously your roof sheeting was fixed with screws. So they take out that screw and they use that same screw to fix their sort of structure that they have for the solar panels on your roof. That's nice because now you don't have more penetrations. You want to limit the amount of penetration. And you want to make sure that the correct type of screws are used to make a tight seal when it's fitted properly. So yes, definitely. On sheeted roofs can create problems, but they can use the same holes. On a shingle roof like this one here, it'll be a bigger problem because those things are nailed underneath each other onto the battens. So if they now install, they'll definitely make new holes, but not, like I said, not necessarily a problem. You just have to pay special attention, make sure that it's done correctly and that the correct details are followed when it's done. And then same goes for concrete flat roof slabs. So you want to prevent, and it goes back to the same thing. You want to prevent making holes through the horizontal surfaces because water tends to stand there for longer. So because water stands there for longer, you allow it time to then penetrate the surface. So if you have the opportunity, fix to something vertical, like the side walls or something like that, because water cannot pond there for that long. So if water gets in there, it will be a little bit of water that runs in there. So that's why you try to do things like that. Then, okay, so if we look at this detail, so what will happen here if you look at that pipe there, so that's sort of just a bigger version of that pipe. So water will run, it will rain, water will run on this surface, it's on the roof, so it'll run there, and water will run down this pipe. So you want to prevent water to run down the pipe and in there. So you create sort of flashing, which we'll have a look at now also. So that one goes up and then connects to the pipe. So that prevents water on this surface to run in there. But now you create sort of a weak point here. Then you want to make sure that you protect that. So then you install sort of what they call counter flashing sometimes. So that's around it. And then it goes down so that water then could run over that junction. Obviously, that's now a weak point there. So you have to make sure that this thing is very nice and tight. It's sealed properly. And like I said earlier, these things, you'll just have to maintain them on a more frequent basis. You have to go up to your roof. You anyways have to go up to your roof to go and clean your gutters. So the gutter situation, the reason why you want to clean your gutters is that if you don't clean it, the water will pond and your gutter looks like this. So if you let water pond, it will go over the side of your gutter. And if this is the inside of your house, it will just run into the ceiling or something there. So that's why you want to clean your gutters. And while you clean your gutters, make sure somebody check all these things while they're up there. Then this is just, I want to just show you flashing, and this is quite an elaborate detail, but very nice. You won't have problems if you do that. So flashing is, so this is your roof, and then sometimes, so you call it a gable wall or something like that. So your roof ties in with this gable wall. So on the side there, so this is the roof then joining the wall. So there you have flashing, because it's difficult to let that sheeting join the wall nice and neat without weird openings and things like that. So then you install this flashing to make sure that it's nice and neat and sealed off. So you have that flashing that goes up from the sheeting up, and then similar to the previous one that I showed you, you have that counter flashing to protect that weak spot there. So same scenario. So now you have that double sort of protection. So very important. So this one here, what is nice about this one, you see in this detail there, you've got that weak point there, because that's probably like a polyurethane sealant or something that like that. And polyurethane is just something that's flexible, so it can move. So it will over time be able to move, because this wall there and that thing there will move differently. So you want something in there to allow that movement and sort of follow that movement and open and close as it opens and closes. But over time, it will lose its flexibility, and then you have to replace it. But now in this instance, this is very nice, because you tuck that in, and that goes, I'll talk about weep holes a little bit later. So now that counter flashing is going through this wall and up and inside. So water will just run over there. So you won't have that problem, and anything in that cavity will run out. So very, very nice detail. Obviously difficult if you do it after the fact and later. You have to do it during your original construction. You can do it after the fact, but during construction, the easiest. So those are sort of your problem areas on roofs: penetrations and at the flashings. We'll talk about flat concrete roofs just a little bit later. I just want to show this quickly. This is nice in Joburg. I'm here today. Look at your nice skyline there. So what? Obviously not as nice as Table Mountain. Sorry, guys. But decent.
Careful
So,
now.
so this is, I see this quite a lot. We were driving to the Northern Cape the other day, and I saw somebody busy on a roof actually doing it. And I wanted to stop and tell them, please don't. So you see, so what happens is people, you get leaks inside your roof. Then everybody panics and say, okay, there's obviously like some big issue with it. We have to sort it out. This is the flashing area that I spoke about earlier. Most probably that's where the leak was before they started doing everything they did here, because that's your weak point. So now what happened here is you can see somebody, and everybody knows the sort of pop and lap story. That's a membrane with like a waterproofing compound, and then you apply it on surfaces. So when somebody then came to site, you see this is where your roof sheeting, all the laps in your roof sheeting. But the roof sheeting, if it was constructed correctly, that lap, there's a certain distance that that lap should be. And that's to prevent water from coming in, because the lap is long enough, the overlap is long enough, then water cannot come in. And you lap, if you go down like that, the top one must go over so that water can run over that lap. So now somebody thought that this is the issue, where the laps are and the joints are. Then they went and put all this pop and lap over. Now it's a major problem, major problem. Because now this roof sheeting in that area, water is just going to stand there constantly, because water runs underneath that pop and lap over time, because it does come loose. Then it just stands there. Now that thing corrodes and corrodes and corrodes everywhere. Then you just have to replace your roof sheeting. Where if they did it correctly, they could have just probably sealed and redid their flashing. There would have been nothing wrong with the sheeting. So typical mistake that I see on classic. So this is just your corrugated dew pitched roof. Okay. Then, okay, so I want to quickly just go, we're going to discuss a couple of topics, and I'm just going to sketch it out for you guys. So I'm going to share my iPad quickly. It's just easier sometimes to sketch, because you can see I'm already doing a lot of hand gestures, and that's not always that good. Okay, So I hope everybody can see this. So what we want to discuss is Windows. So I'm first going to go to Windows. So Windows, like I said at the beginning, classic area where waterproofing problems, where you find that. So this is just roughly, quickly, your typical window components. This here is your wall. So this is a section through it. So it's as if you've cut through the wall, and you can see this is a section through the brickwork. I hope everybody understands that. That's a section. This is a section through the window. Yeah, so it's a section. So now this is your window with its frame. That I'll discuss now. That's the waterproof angle. And this is supposed to be your sill. So like I said earlier, you don't want water to stand for a long time. And I'll quickly discuss something here about Joburg, what I see a lot here. So now the way to construct this is your wall is built. So the wall is built now, everything is correct, nice. Then you install, after that, you want to install this waterproofing angle. So the purpose of that is to create something that you can use to dress your waterproofing up, because that then stops the water. So you now want to install waterproofing here. So the correct detail is to install waterproofing there, up to there. You can go down if you want to. That's nice detail, but it's unnecessary. So if you have enough bonding there, you're going to plaster over it. So that is a very nice detail, because this is inside and this is outside. So now if it rains and if water comes, then water will run here and it will probably get to there maybe, but then it will just stand there. It cannot come inside your house or inside the unit. So this is the right detail. So then what you do then after that is you install your window and you plaster a sill. You're going to plaster that sill so it allows, so this is the sill. So a sill is just something that slants away. So you want to plaster that sill, but now you have to be very careful. And I see this quite a lot. So you plaster the sill so that water can, when it comes there, it will run away. It won't stand there. So now, if you've got aluminium or timber, you want to not, sometimes in aluminium windows, you'll see they've got a weeple in here, in that frame. So that's something that if water rains, or if it rains and water gets into that frame, then it stands there. Then that weeple allows water to then run out of the frame. So just be very careful, because I see a lot that people close that weeple, so they plug it with polyurethane sealant, or they plaster this sill over it or something like that. Then you create another problem, because now water will just stand in this area. So this here, what I've shown you here, this is the correct detail and sort of the preferred detail around windows. So very critical, two elements here is this angle that will allow you to create an upturn, because that's what you want to achieve. You want to sort of close it off so that it cannot get in. And then you want to have a sill away from the window so that water can run away. Now, I want to discuss, I'm just going to sketch it out here quickly. So you'll see it in Joburg quite a lot. So in Joburg, I'm going to just draw a section. This is a steel window frame. So this is sort of somewhere along the frame. So that's the vertical of the frame. Then this is where your glass sits. So what you have then typically on here is your putty. So your putty sits there on your window frame. And then the glass sits there. And the purpose of the putty is mainly to keep the window in place. But also that putty, when it rains, water will, same story, run against the window and it will run away. So it does act sort of as a sill. It's not the main purpose. So now what happens a lot in Joburg, people don't maintain, because you've got lots of buildings, old buildings that are face brick buildings, not a lot of maintenance, but they've got these old steel window frames that are excellent windows, but people don't maintain them. So the putty dries out, everybody just leaves it, because it's not a major issue. Then this putty, it falls off or something like that. So now what happens now? Now the water just ponds there. So it just sits there. And then I get to a lot of these buildings, then that window frame is gone. You must now replace it. Very expensive and super unnecessary because putty replacement is so cheap. It's so cheap. You can do it for not a lot of money, but now you've left it for, let's say, 20 years. You didn't do anything to it. Now that window frame is very badly corroded. Now you have to replace it. And that's a massive expense. So just a classic issue around the windows. Then I want to talk about retaining walls. So the reason for talking about retaining walls is it's a waterproofing discussion, but it's also sort of a misconception or something that I just want to talk about. So when is a wall a retaining wall? So this is a wall. So as you see it here, that's the foundation. And again, this is a section through the wall. So that's the wall. So now, typically you'll have soil on one side or on both sides. So that's soil on the one side. Then if you've got soil on the other side, like this here, and it's on the same level, then it's just a wall. It's just a boundary wall, freestanding wall, nothing funny about it. Obviously, also a lot of regulation around it, how you should construct it, what's the right thing to do, blah, blah, blah. But it's not a retaining wall. It becomes a retaining wall when this happens. When the one side is higher than the other side, because now it retains something. So this height is the retained height. So that's a retaining wall now. Then, because of that, so let's just quickly go back to the previous situation. So if you have a wall like this, where it's on the same level, obviously everything under here there will be moisture in here because it rains, water gets into the ground, it stands there. So naturally, this wall will also have moisture in it because you don't have to waterproof it because it's just outside and outside. There's no real repercussion. Maybe over a very long period of time, the wall will be in a very poor condition, but that will take a long time. So, and then because of that, water will rise up slightly in this wall. So you'll get moisture a little bit above this ground level for the reason because this goes up in the wall, and also just because when it rains, water splashes there and there's a lot of water against the wall. So that's why there's moisture in the lower sections of your wall. So now let's quickly go back to retaining wall. When it's a retaining wall, then it's a different story because now this side is usually a side that you see very often. So you see it, what's inside your house, what's inside a basement garage or something like that. Now you want to waterproof it because it's just doesn't look nice. So, and the way to waterproof it is to start from the top, go down, waterproof, and you can even turn it down there. Then you know you're covered. But then there's also more stuff that you have to do. You have to install weep holes because you want to prevent water to build up behind the wall. So you install what they call subsoil drain. So subsoil drain is just a drain that runs here. It can sit either below that level there, but then you have to connect this pipe somewhere down the line to a manhole or something. If it sits above that level there, then it's obviously easy because then you can just have like these spouts that go through the wall. So then water will run down here, it will collect in this pipe and it will run out there. Then you make sure that there's not a buildup of water behind your retaining wall. And like I said, that's also for two reasons, because then water stands there for longer and you give it more time to penetrate your retaining wall. And also that pressure buildup is not good for the wall. I want to quickly discuss just negative waterproofing. I'm quickly going to touch on that. So negative waterproofing, it's something that you guys might have heard of before. So this is positive waterproofing. Positive because it's on the side where the moisture is coming from. So moisture in this instance is coming from this side here because there's moisture in this area here. Negative waterproofing means that you're not going from the side where the water is coming from. You're going to waterproof on this side. So you see an issue there. Now you rather, let's say it's a basement parking, you've got nice plants in here, bougainvilleas growing beautifully. Nobody wants to take it out, blah, blah, blah. Now you decide, no, let's rather waterproof on this side. The issue with that is that, okay, temporarily you will stop the water from coming through here. But the issue is that water just sits in this wall now. So like I said at the beginning, the one thing is you want to protect things on this side, like let's say your ceiling or your furniture or your carpet or whatever. But the very, very important thing is you want to protect your structure. So you want to protect this thing. If this is a reinforced concrete wall and you just allow moisture to constantly get in there, you'll get spalling. So this is negative waterproofing, not always a good idea. It's sort of a short-term solution. This is positive waterproofing. It's not nice because now you have to take out your nice bougainvillea there, but you just have to bite the bullet because otherwise you're going to have to do it sometime along the line anyways. And then you've wasted this money to do the negative waterproofing, then you anyways go back and you take this out. So quick thing that I want to discuss is foundation walls. So foundation walls is this thing here. It's this portion here at the bottom. So from your foundation up to sort of where your first floor sits. Then this is called superstructure brickwork. So that's everything above it. People a lot of times think that when you have damp here, then it's the end of the world, and we have to do major things to it and waterproof from this side. And I see a lot of that. People apply waterproofing that side. It's not going to work because unless you have lots of water here for some reason, but that's highly unlikely. But these walls here, that's why you have this DPC. So this here is the DPC so that's just black plastic or something that splits this wall from that wall. So it prevents water from traveling up and into that area there. So it's a bond breaker, or it's just something that's not porous that water cannot go through. So now this area here will typically have more moisture in it because it's in the ground, it gets moisture. So that's why you'll see if a building wasn't maintained frequently, you'll see more issues down here at the bottom below the DPC line because it's just in the moisture and in the wet sort of area the whole time. So it just means you have to prepare it, paint it, and move on. You don't have to do something major unless you want to waterproof the whole thing here, but that's unnecessary. So I want to quickly talk about weepoles, why we are here. So that's your DPC, that's the weepole. So weepole is not waterproofing per se, but it allows water to come out of your cavity and not sit here and then cause problems on the inside of your building. So water will drip down your cavity onto this plastic and will go out. Water doesn't go in at a weepole and then causes problems unless it was constructed incorrectly. If it was constructed correctly, the water will go in here and it will just roll out again. So don't close up weepoles. I see that a lot. People close up weepoles. Then all you do is you block this off. Water ponds in here, then you have issues there. So then, okay, let's get to balconies while we are here. So balconies, this is your typical sort of balcony, also a section. This is the concrete slab here. This is the upstand on the edge of your balcony, and I'll explain why this is nice to have. And then this is your flat area where you usually have tiles or something like that. That's your door. This is inside, outside, and this is your balustrade. So let's quickly talk about the upstand. The upstand there, the nice thing about that upstand, so in a lot of buildings you don't see the upstands. You see it in a lot of buildings also. The good thing about that is that when you have water runoff here, so if you have water here, then you can guide it through a pipe, which you call a spout, or you can have an outlet somewhere or whatever. So you can have a spout there. So now you can guide that water to run out and far away from your building and drip off. Then it's nice. It doesn't affect the facade of the building, all of that. If you don't have this upstand, so let's say this upstand is not there, then what happens is that it's flat. So now water just runs here and it runs there, and then you see those streaks a lot of times on the edges of walkways and balconies because water just runs over and it's dirty and it makes those streaks over time. So that's why you want to have that upstand. So I'm quickly going to talk about the details. So the details, that's typically like how you terminate at your door. How do you terminate on this edge here? So what do you do there? Do you go with the waterproofing behind the plaster? So this is your plaster. That's a nice detail because then you don't have the problem. So your plaster goes over everywhere. That's a nice detail. Or do you go with your waterproofing all the way up and over and down again? And then what do you do in this area? You know, what do you do there? Another detail that's important is at that outlet that we discussed earlier. So how do you end in that outlet? So let's say you have that hole now through here, then you have to dress that waterproofing nice and neatly into that outlet. So that's your waterproofing that runs on the surface. You want to dress it in there, you want to dress it in there, so that if water comes in there, that it doesn't penetrate the wall in here somewhere, it runs out. So that's the details that I spoke about earlier. That's very important. Okay, that's the end of this whiteboard presentation. Sorry, I'm rushing a little bit now because I'm
Philip, can
talking
our
for too
next
long.
presentation be on how to use a whiteboard?
Yes, definitely.
I'm so impressed with your sketching there. It's amazing. Well
I told
done.
you you were going to cause havoc for me, Philip. I warned you.
So yeah, I hope it helped. For me, it's nice to see things, and it's better or easier to explain also. So I hope it helped with the understanding of the concepts. So this is a weeple that I discussed earlier. You see there, nice weeple doing its work. Water inside this cavity, dripping down and running out. So don't close it up. You'll just allow water to stand there. Then if you do waterproofing, so we discussed all the issues now, where the typical problems are and things like that. So now, what do you do when you have a waterproofing problem? First thing is find the cause. Don't just remedy the corroded rebar and concrete and paint and stuff like that. Find the cause, sort out the cause, and then you only start with the project. Then look at what you are waterproofing. Are you waterproofing a small balcony? Are you waterproofing a shower? Are you waterproofing a massive roof area? Are you waterproofing a long walkway? All those things play a role in the type of product you should use. You can't just say, okay, we love the Sika Semflex product and we're going to use that everywhere, because it's not fit for purpose on all the different areas you have. You've got lots of different waterproofing products. You've got bituminous waterproofing products. You've got cementitious waterproofing products. You've got polyurethane waterproofing products. You've got EPDM, which is a rubber. You've got so many different waterproofing products, and each one of those products is fit for a different area use, what you put on top of it, and that puts me here. So your substrate is extremely important. You have to know on what are you applying that. Is it on timber? Is it on screed? Is it on concrete? Is that screed a very good screed? Things like that. So your substrate in deciding what type of waterproofing you want to use is very important, but also in making sure that the final solution is executed correctly is extremely important. If that substrate is not sound, it means your waterproofing that you've applied over it won't stick to it. That thing will just crumble over time, and then the whole thing fails. Then very important also is to know, what are you putting on top of the waterproofing? Are you going to tile on top of it? Are you going to leave it exposed? Are cars going to drive over it? You know, something like that. You need to understand what's going on top of it. Only then can you design the solution. And then you have to decide on the products and the guarantees that you want to use. So for that, you use consultants, or you use the waterproofing manufacturers. So there are lots of waterproofing manufacturers: Sika, ABE, Stonecore, you know, Mapei. Those are all very big companies that supply the products, and they can give you guidance on what is the correct product for your building. Obviously, you can also use consultants. So we consult a lot on that side, where we give you guidance. We say, okay, this is your area. These are the type of products that you have to use, and so forth. Then, like I said before, details. There's somebody in the office still typing details there, just so small you can't see it. Somewhere there, it's going on. That's how important it is. And then quality control. Obviously, it doesn't help that you do all these things, you plan properly, but then when the project's done, then nobody keeps an eye on what's going on actually. So during the project, you have certain checkpoints where you have to come in and make sure that it's done correctly. So look for approved applicators. When you've decided on your product, they can tell you this is an approved applicator. This person has training with our product. They know how to apply it. They know what to do, and use consultants to guide you. Details. I want to make sure that everybody understands it's not just about the waterproofing. The problems are always at the finer areas where the details are of concern. So I've discussed walls and I'm running out of time now, but load-bearing walls, I just want to touch on it quickly. You can't say if a brickwork wall is 110 millimeters wide, it's not a load-bearing wall. It's not the case. You have to look at what that wall is actually doing. Is that wall supporting something? If it does, it's a load-bearing wall. It was maybe not designed to be one, but it is now a load-bearing wall. So you can't just say it's 110 wall, knock it out, boom, there we go. Freestanding wall, I discussed that also earlier. There's a freestanding wall is typically like a boundary wall. That's just where you have a wall that's running. The soil is sort of the same level on both sides. That's a freestanding wall. It's typically a boundary wall. An infill brickwork wall, that's a wall. Let's say you have a concrete structure with beams and columns and things like that. Then it's just to close up the building. So it doesn't carry any load. It's just an infill brickwork wall. So if you have a crack in that, it's not as serious. And then retaining wall is what we discussed earlier. This is the SNS regulations. So you have a lot of information in those documents about walls. This is just 2 pages in a very long document that you can go and read on. It tells you exactly how high, the maximum height you can build a wall, the spacing of your piers, the size of your piers. There's lots of things about that. Then, okay, so now we get to the prize. It's 1 of 2. So I want to ask you guys a question quickly, and the first person to comment the right question, the right answer, will get a voucher from us. So if you think about negative waterproofing, does negative waterproofing protect the structure or the element that is damp? Okay, A, only if applied correctly. B, no. C, yes. Vinnige vingers.
That's a difficult one. No one's hands are going up.
No time for it.
We've got answers in the chat function. I see the first person that
answers in-
posted was Carmen.
Carmen.
B. Is that right?
Yes, Carmen Overmeyer.
Lekker.
I'll get your details, Carmen, and then I'll send something to you. Congratulations. It doesn't protect the structure. It's a quick fix on the wrong side. It's better to go to the back and then protect everything properly. So now, okay, I'm going to touch on this quickly, but I've sort of spoken about it along the way already anyways. When you do maintenance projects, plan properly. So we assist clients with that. You have to package your projects properly. People go straight into sort of, let's do the project, let's get a builder and we tell them to paint our building and there we go. There's a lot of people underestimate the amount of variables in a building project. There are so many variables. If you think just about painting a wall, how big is that wall? What is the length of the wall? What is the height of the wall? What is the wall made of? Is it plastered wall? Is it a rough brickwork wall? Is it a timber wall? Is it a concrete wall? You have to answer that question. What type of paint do you want to use? What manufacturer do you want to use? What's the duration of the guarantee that you want? Those are all questions that you have to ask just when you think about painting a wall. So that's not painting a whole building, then that escalates that amount of variables. So your design, it depends on the complexity of your project, and you need drawings or details, you need specifications from your suppliers, and you have to decide on the products and the guarantees you want to use. You need a bill of quantities for a project. You need to tell the contractor this is how much you have to do. So the bill of quantities tell the contractor how much he needs to do. This tells the contractor what he must use to do it, and this tells him how he must do it. Then execution, obviously very important. So after you've done your planning properly, then you may have to make sure that your execution is proper. So I'm quickly going to use this example. I use it a lot. If you think about a project and you compare it to buying bread, if you go to 3 different bakeries and you ask them, can I please get bread? Then the first guy, he just wants to do business. He's going to see you. He's going to give you the cheapest bread that he can give you. He gives you a half loaf of bread. The next person sort of, they're very proud about their business. I'm not saying the half loaf guy is not proud about his business. I'm just using an example. So this person says, you know, we only want to sell healthy bread to people. This is your full grain loaf of bread. The next person thinks that you've got a family at home, you want to feed all of them. They give you a whole price for a whole basket of bread. They all have priced you for bread. You ask them for bread. So now, if you go to the cheapest guy, you're going to get a half loaf of bread. But if this guy gave you a half loaf of bread, it would have probably been cheaper. Or this guy, they would have given you a half loaf of bread for cheaper. But because you didn't tell them, I want a full grain loaf of bread, they all priced different things for you. So it's the same with a construction project. You have to tell people exactly what you want. And there are much more variables than what people think. This is a bill of quantities, just a quick example. This is just to fix a crack in a wall. So there's a little bit of underpinning and building the foundation again that needs to happen there. But look at this is only some of the line items to fix the crack in the wall. So you give the guy or the person the line item, you give them the unit of measurement, the quantity, then they just fill in the rate, and that gives you a price. So that's a bill of quantities, and that's part of what we prepare when we run projects for people. Then you get to choosing the contractor, which is part of your procurement just before execution. So important things to take into account is the competence, the compliance, and the cost. So those are sort of the three things you look at. Competence, we measure by looking at the site management or the organogram of the contractor. Compliance and checking references. Compliance is we look at just their documents, so their company registration documents, tax clearance certificates, their insurance that they have, all those things. Then BRBC registration. Then cost. You can only accurately compare costs if you have a bill of quantities. So otherwise, you just look at lump sum and you can't compare people's costs. You can really only compare it if you have a detailed breakdown of what they're pricing for you, because then you can see if it's too expensive or not. And you want to find that perfect balance. So you want a good contractor that's fast and cheap. If it's good and cheap, typically slow. Fast and cheap, then usually low quality. If it's good and fast, it will be very expensive. And that one there in the middle is very difficult to find. If you find it, it's a unicorn. And you must tell us about that unicorn, because we also want to use them on our projects. Or then contracts just quickly, and Zelinda, they will tell you all about it because that's their specialty. So contracts, if you look at a quote is a one-sided agreement from the contractor telling you, these are my terms of how I want to do this project. You have to use contracts that protect your side also. There are lots of financial risk, quality risk, and timing risk items that aren't addressed in just signing up on a quote. So these are typical in the JBCC items that needs to be addressed. The client must provide a payment guarantee. Contractor must provide an advance payment guarantee if they want a deposit, otherwise no deposits. And the contractor must provide a performance guarantee or retention. I don't have time to go into more detail on that now, but we can do it some other time. Then quality, the contract also protects you against that because there's a latent defects liability period that says after the contractor has completed the work, they are still liable if there's an issue that you only identify afterwards to come back and fix it. And then timing, the JBCC protects the client as well as the contractor with regards to timing, because it says there's a start and an end date. But the contractor can, during the time, say, okay, I want extension because of this reason or that reason, or it rained, or the client changed the details or things like that. And obviously the client is protected because at the beginning you already said that's the end date. Then, yeah, that's just my conclusion for this last part is, do your planning properly, use consultants if you can, and then be very clear about your brief of what you want to do on your project. Because if you're not very clear about what you want to do, you will have a certain expectation in your mind. The contractor will have priced you for something differently. And then, you get to just everybody's unhappy at the end, and use contracts. Because otherwise, this is your expectation. And this is what you got, and the contractor thinks that he nailed it. So thank you very much, everybody. And sorry for rushing a little bit at the end. I didn't want to keep you for too long. I know everybody is very busy. Again, I just want to thank you, Zelinda and her team, for setting this up. I think it's amazing. I think these things are so important to uplift the whole industry and just to assist each other and share knowledge, because we all want to make sure that everybody at the end have good projects and buildings that are well kept, and communities that people are happy because everything is going well. So I think these things are very important to achieve that.
Fantastic. Thank you so much, Philip. I super enjoyed it and I learned a couple of things, which is going to help me in my practice, which is really, really great. And I learn something new every time. And every single time I see that picture of that unicorn, I still laugh. And I've seen it quite a few times now. For those of you that have joined our Let's Get Physical event, you would have heard some of what Philip has spoken about today. And he's going to be chatting about it at our Let's Get Physical event in Johannesburg. For those of you that are based there, I know that Carl mentioned that earlier, as well as the Naba Expo, I'm sure. So thank you very much, Philip. We do have 1 or 2 questions in the chat that I wouldn't mind you answering. So if we could just spend another 2 or so minutes, is that okay, Philip? Cool. So we've got a question from Peter. He posted right at the beginning. He said, hello, Philip, would you recommend liquid injection waterproofing as an alternative method, thereby creating minimal disruption?
So liquid injection will be where you put it into a crack. So typically, like I did touch on it briefly during the presentation. So the thing is that you're going to seal that crack, yes, and you'll seal that crack probably well, but the crack is not necessarily the cause of the water ingress. So there might be a crack just a couple of meters away, and then you've sealed this one crack with liquid injection, but the water will just find its way now to this other crack. So it depends on the situation, but sort of off the bat, I'm sure that that product wouldn't have been developed if there is not good uses for it. So maybe if you have joints where the joint has now failed and you want to not go behind the wall or you cannot access it, then doing liquid injection, yes, that will work. But if you seal cracks, I won't necessarily say it's a good thing, because we were at a big building here in Joburg, very recently developed, where they've done exactly that now. The waterproofing has failed at the top. Lots of cracks in the basement parking slab with planters and stuff over it. And exactly what I just explained happens. Seal one crack, water comes through at the next one. Then seal the next crack. So it just moves on and finds its way through. The issue is at the top. The waterproofing is not sound. Water is getting into that concrete. So, but yeah, it depends on your situation.
The next question is from Anne. If you have a garden wall 4 meters wide with a meter high soil against it, is it now a load-bearing wall? The wall is cracking horizontally.
So horizontal crack is not good. That means that there is a problem. So 4 meter wide, I assume long, probably 4 meter long, and with a meter high soil. 4 meter wide wall can be, but then there must be something in it. So a lot of concrete or something. I assume 4 meters long and 1 meter high soil against it. So 1 meter high soil against it means it is a retaining wall. It's retaining something. It's not retaining a lot. So it's not a massive retaining wall. Load bear, so it's a retaining wall. It does support load, horizontal load. Typically, when people talk about a load-bearing wall, it supports vertical loads. So that's a load-bearing wall. A retaining wall supports loads. It can also support vertical loads. Then it's a load-bearing wall, but it does support load, horizontal load. But you generally refer to that just as a retaining wall and not a load-bearing wall.
Interesting.
So. Well, and your question is no, yeah. So it's more a retaining wall. I won't say it's a load-bearing wall.
Load-bearing wall. Okay.
But it does bear load if you look at the phrase, but it's horizontal load. But in the general sense, load-bearing is more vertical load.
Fantastic. Gee whiskers, so much to learn. I don't see any more questions on the chat. We're going to send you the questions just for your side. And if you'd like to send us some responses in writing, you're more than welcome to do so, and we'll post them. Is there anything from the floor before we say goodbye for today? There's a lot of thanks and quite a lot of people that are impressed with your technological skills. So Philip, thank you very much for your presentation today. I don't see any hands that are raised, just a lot of thank yous. Very informative topic, a very good explanation on a very tricky topic. So yeah, great as always. Philip, thank you so much. And now you can go take over from your lovely wife and spend some time with Olivia.
Thank you very much,
After
Linda. I appreciate
a
it.
busy working day. Fantastic. Thank you so much for joining, everybody. Please feel free to catch the recording. If you have any questions, do reach out to us. And you would have seen that I shared Philip's details, his website, his email, his cell phone number. So do get hold of him. In Cape Town, the weather is changing quite quickly, so I'm sure that you're going to be kept very, very busy at home. But we'll see you soon in Joburg. Keep well, everybody, and have a good week further. Bye-bye.
Thank you very much. Bye.